Hi everyone, welcome to your PlayPosit for the week. We are going to be covering lessons that correspond in your OMHS to 1.02, 1.04 through 1.06. So go ahead and grab your notes. They were posted on your plan and we're going to get started. So today we're going to go over simplifying expressions, determining if two expressions are equal, and some translating. And oh my gosh, this makes me laugh every time I see it. Y'all don't have to worry about this because we don't have handheld calculators anymore, right? You have the free Desmos graphing calculator that we're all using. I'll never forget one time that I worked in brick and mortar. I was trying to open my classroom door and I was using my thumb drive instead of my key. This meme kind of reminds me of that. The remote instead of the calculator. Oh man. All right, let's get started. So this is a question actually from last class that we did not get to, so I wanted to make sure we went over it. It's a multiple choice question asking what the value of x is that will make the given equation true. So that just means the left-hand side is going to equal the right-hand side. So there's a few ways to tackle this problem. Don't forget that at any time you're watching this PlayPosit, you can hit pause. You can always try the questions on your own and come back for the answers. There'll be some like automatic built-in pauses for you, but if you ever want to pause, you can do that as well. So what we can do is we can take each of these x values, plug it in for x, and see if it's true or not, or we can just solve this for x. Let's solve this for x and see what we get. So the goal with solving, remember from math last year, is you want to get all the x's together. So we have a term here with an x and another one here. So we've got to combine those. Those are like terms. So this is a minus 12x. Do you remember how to get this to the other side? You have to do the opposite operation. So since this is minus 12x, we will add 12x to both sides. And we'll do the math vertically. So 4 plus 12 is 16. Bring down the negative 3 and bring down the 13. 12, negative 12 plus 12, that's 0, right? And that's what we wanted to happen. We wanted it to move to the other side. Okay, we're getting there. Now we want to leave this term by itself and move the 3 over. So this is a minus 3. The opposite is plus 3. The inverse operation or the opposite operation. Bring down our 16x. 13 plus 3 is 16. Last step here, this is 16 times x. So the inverse or the opposite operation of multiplication is division. So we'll divide 16 on both sides. Remember, whatever you do to one side, you have to do it to the other. So x equals 1. And here's our answer. So let's look at the other way we could check this. So if we were to plug in 1 for x on the left-hand side and 1 for x on the right-hand side, if it works, it's going to be equal to, right? So 4 times 1 is 4. Negative 12 times 1 is negative 12. 4 minus 3 is 1. And negative 12 plus 13 is 1. So sure enough, that is true. The left-hand side does equal the right-hand side. Let's try another one. What is the value of x that makes this true? So if you look at this, maybe you want to solve it the way we did it. Maybe you want to try to plug in values and see which one is true or which ones are false. Let me show you on our Desmos calculator. So this is, I'm just going to write the problem down really fast. I have a terrible short-term memory, and I know if I went to Desmos, I would totally forget. But you all have your notes in front of you. All right. This is a brand new computer, so I don't even have anything like linked and saved. I'm gonna have to do that. You guys can do that with me. Let's see. I want the Virginia version. This is not the Virginia version. Come on, Desmond. Here we go. Excuse me. Okay, did you see those differences there? This is good. This one has the black bar at the top. It does not say Virginia. This is not the one we want to use. And we're going to get more to this later, but it has different settings than what we need. We want to make sure it has the green bar at the top that says Virginia. So our problem was, let's see. All right, so we'll just put each of our functions over here. I call them functions. So x divided by 4 plus x squared minus 3. That's the left-hand side. And then here's the right-hand side. Now it is graphing. That's okay. You can turn the graphs off if you want, if it's kind of bugging you. And let's try 16 first and see what happens. If we would plug in 16 for x, we get 257 on the left and 55 on the right. So that doesn't work, right? But they have to be equal. Let's try 8. We get 63 on the left and 63 on the right. It could be 8. Let's double check all the answers. It's always good to make sure that the other ones then do not work. Yeah, those are not the same, right? 1.5 is not 69. And try 0. We know it's not going to be 0, right? Definitely not. So the answer was 8. Let's look at that again. We plugged in 8 on the left and 8 on the right. They match 63 and 63. So the answer is B. We could solve this by hand also, just like we did the last one. I'll save that for a future date when we get more into solving equations, especially with squareds. This is another way you can do it. Take each of those values, plug them in for x, and see when does the left equal the right. All right, simplifying with fractions. Now we know we have the Desmos calculator, but we can also do these by hand. And we want to remember PEMDAS that we covered in our live class, or GEMDAS if you're used to that. So we'll start with the parentheses first. Remember, when the denominators are the same, you can go ahead and add and subtract the numerators. So we'll have 7/3 plus 3. 2 minus 1 is 1 over 3. And that's it. When the bottoms are the same, you can go ahead and do what you need to do to the tops, to the numerators. All right, now exponents come next. 1/3 squared is 1/3 times 1/3. And with multiplication, you just do the top times the top and the bottom times the bottom. So we'll have 7/3 plus 3. 1 times 1 is 1, and 3 times 3 is 9. All right, our last multiplication here. If you want, you can make them look similar. Like this is a whole number. We'll put it over 1. Now you have a fraction, right? Kind of is more pleasing to the eye when you're multiplying fractions. So 3 times 1 is 3. 1 times 9 is 9. Last step. So when you're adding and subtracting fractions, remember the denominators must match. In this case, they don't quite match. We have some options. We can either make this one a 9, or we can, in this case, make this one a 3, right? Can't we reduce 3 over 9? 3 goes into both of this. So 3 divided by 3 is 1, and 9 divided by 3 is 3. Now the denominators match, and we can go ahead and add the numerators. 7 plus 1 is 8 over 3. Now I want to show you in the Desmos calculator. Let me jot this down really fast. Thing about the calculator, it's great, right? You can check your work, but you want to make sure you're entering things in carefully. So I'll close this. Remember, you have your scientific calculator here at the bottom you can pop open. So we'll just do 7 divided by 3. My cursor is like stuck in the bottom, so I'm going to hit the arrow over. If I did not hit the arrow over, watch what happens. See, it like stays stuck in the bottom. So you want to arrow over, plus 3 times 2 divided by 3, arrow over, minus 1 divided by 3. Arrow over, and squared. You can grab the squared here from the keyboard, or you can hit, mine is above my 6, the little caret button, shift 6 and 2. There we go. Now it's a decimal. Here's that fraction button, and you do get 8/3, which matches what we got by hand. It's a great confirmation of your work there. So let's look at this one. If we did the other one by hand, let's do this one straight on the calculator. I think I'm just going to edit this. Look, you could retype it as well. So 5/4 plus, I'm just using my mouse and I'm like clicking on the spot that I want to edit and deleting. 3/4. So nice. There we go. And double check I did it right. 5/4. Yep. And the answer is 3/2. So here is the answer to the challenge. I want you guys to try this on your own and double check that you did get that answer. Of course, you can use the Desmos calculator as well. So let's talk about the difference between an expression and an equation. We use these words a lot in algebra, and really the main difference is an equation has an equal sign and an expression does not. No equal symbol. We use expressions and equations all the time to model different things in our lives and in our class. So that's the difference. And you can remember because equation has equi in it, like equal to. So let's look at the parts of an expression. I'm going to write an example here. Like, how about, I'm just making this up. And then, okay, here's an example of an expression. There's no equal to symbol. We just have some, well, what I'm going to call them are terms. How many terms do we have? There are 3. 3 terms. Terms are separated by addition and subtraction. Terms are separated by those symbols. So in this example, we have 3 terms. We also have something called a leading coefficient. The leading coefficient is the number in front that is with the highest exponent value. So that's a little misleading. You see the word leading and you think it should be the one in the front. That's not always true. What if I had this example? See, this is the highest exponent value. That makes this the leading coefficient. So you want to make sure you're grabbing the number in front of the highest exponent value. So in this example, it's 3, the number in front of the highest exponent value. You can have just regular coefficients like, let me get, oops, I need to get another color, but my pen is being funky on me. These are all coefficients. Well, the 3 and the 2 are coefficients. Coefficients. They are numbers in front of variables. Technically, the 6 is also a coefficient because you could say that it's in front of the 0x term, but we don't really say that because 6 doesn't have a variable with it. This is called the constant. It's constant because it's not going to change. No matter what x is, that -6 will always stay -6. This second term here, if x is 1, this term is 2. X is 2, this term is 4. So it changes. So this is not constant. All right, so I have an example. I love this picture. This is from when Sophia was like 9 months old. She's 4 now. She's so little. All right, so Miss Winslow pays a babysitter 1 to 2 hours per week to watch her youngest daughter, Sophia, while she attends some meetings. This is true. This was true. Now she goes to preschool. The sitter, who happens to be super qualified, charges a flat fee of $10 per month that helps cover her CPR certification, and $15 per hour. So can you come up with an equation for me to use for budget purposes? How much do I owe her if she watches Sophia for 4 hours? And how much I owe her if she watches her for 8 hours? So this is kind of a sneak peek of some of the work we're going to be doing with expressions and equations and translating. And we're not going to solve this today, although I bet a lot of you already are putting the solution on your paper, and that's great. Go ahead and brainstorm and see if you can figure this out, and then we will do it together in about 2 more classes. Okay, so here's some examples where we're going to evaluate expressions where they give you some kind of value. So it tells us to use x is 1 and y is 3. All that means is wherever you see an x, put 1. And where we see a y, put 3. It's as easy as that. And then you simplify the expression. So 3 plus 9 is 12. 12 minus 1 is 11. Let's just double check. Y is 3, x is 1. Yep. Let's try this one. So y is 10. Z is 2. And then we can, by hand or with the Desmos calculator, simplify the expression. So this is an expression right here because there's no equal to symbol in it. Parentheses first, up, but there's an exponent. So 2 squared is 2 times 2, which is 4. 2 plus 4 is 6, and 10 minus 6 is 4. There we go. You'll see problems like this in your OMHS and on our assessments. So practice continue. They can get, I wouldn't say harder, maybe just longer. So you kind of have to keep track of everything. So y is 2, x is 7, z is 4, and y is 2. And now we can simplify the expression. 2 over 2 is 1. You can do this by hand or with your calculator. I'm just going to kind of start combining things, right? 1 plus 7 is 8, 4 plus 4 is 8, and 16 plus 2 is 18. All right, true or false? If we were together, I would be quick polling you. Number 1, do you think this is true or false? Think about it first, and then we'll show you the solution. Let's see. 4 minus 3 is 1, and 3 minus 4 is negative 1. Wah, wah. That is not true. Nope. 1 does not equal negative 1. Let's see number 2. So this one I always want to go over because they kind of look very similar. They are very different. So you can see here this squared is covering everything inside the parentheses. That means you're going to square everything. Over here, this squared is just touching the big 2. That's it. So you're only going to square what it's touching. You're only going to square the 2. So this is negative 2 times 2, which is negative 4. This is negative 2 times negative 2, which is positive 4. These are not the same. This one stumps a few people every year, and even sometimes as I'm doing problems too quickly, it'll get me too. So I'm sharing it with you because I want you to be extra careful that when you see parentheses, make sure you're squaring everything. When you don't see parentheses, make sure you're not squaring everything, right? We only want to square what the exponent is touching. All right, so now I want you to write all the words you can think of when you see these symbols. And I'm not even going to be able to add all of them because I don't have enough space. But when you see the plus symbol, I'm sure you're thinking of add, sum, together, addition. There's so many more, right? And the subtraction symbol, maybe difference, less than. How about multiplication? Oh, I always think of product, multiple, like multiple of things, multiply, division. What do you think of when you think of division? Oh, I always think of quotient, like the quotient of 2 numbers. When you see this is what I'm talking about when you have an X now in algebra, you might see words like Might say some number. Like the product of 3 and some number. You can call it x or y or z. And equal to, I always think of is, right? Like 2 plus 5 is 7. So this is getting our brains ready for translating. Translating in math is kind of like a different language. You're taking English words and you're putting them into math words, basically. So here are some other words you can fill in on your spaces, and I didn't have parentheses on our last chart, but this is also a good one. The quantity of, twice the sum of. A lot of times when you see the word of, I also think of with multiplication. What you think of with parentheses, right? Because if you like do this, parentheses, whenever there's a number next to a parentheses, it always means to multiply. Oh, combined, that's a good one. So jot some of these down in your chart. You can also take a snip of this. All right, let's do it. Let's translate. Look at this. Think of a number. Don't tell it to me. Double it. That's this part. Just say, okay, when you got it. Add 6. Half that. Subtract the number you started with. Your answer is 3. So Drake is doing some translating for us. Thanks, Drake. So let's practice. We're going to take these verbal expressions and translate them into algebraic expressions. 2 less than a number. There's that clue word, less than a number. And oftentimes when we see less than, we have to take it off the back. Meaning, if you said like 2 less than 5, think about how that would look. 2 less than 5. Wouldn't you write that 5 minus 2? That's what you do in your head. So 2 less than a number, let's call the number x, and we're going to take 2 less than that. So you have to take 2 off of the back of the number. You would not want to write 2 minus x. That's not 2 less than x. Like what if x was 10? Then our answer would be negative 8. That's not 2 less than x, that's 2 more than x actually. So make sure that when you see less than, it comes off the back of the thing. It's almost like in reverse. All right, a number minus 2 equals 3. A number. So when you see it written like this, it's okay. It's telling you exactly how to write it. A number minus 2. It's that less than that really can trick you up. So a number minus 2 equals 3. 7 more than 2 times a number. Now addition, remember order doesn't matter, so you could write this as 2x plus 7 if you wanted to. They do mean the same thing. Number 4, 7 plus 2 times a number. You can see those are the same. I just wanted you to see the difference there, more than or plus. The square of a number plus 5. So a number, square it, plus 5. 5 times a number is 30. 5 times a number is 30. And 16 divided by a number. I use X for all numbers. You could use any letter you wanted to. Some more examples. This time we're going to go in reverse, and there's going to be a few different ways you can write this. So if you wrote it a little bit differently, that's okay. Remember that chart we looked at had a bunch of different words that meant the same thing as product. A bunch of different words that meant the same thing as addition. So it just kind of depends which words you choose. Let's see. Number 1. I might say 9 less than a number. You could write a number minus 9. Excuse me, that would work. How about number 2? I'm going to write the sum of a number and 4 is 5. Oops, I meant to write out the number 4. There we go. And the number 9. So in this case, I chose to write sum for addition. I don't know. I think this is kind of fun. It's like a game. Like, how can I make this match? Number 3, the product of 3 and a number. And then you might say added to 7, right? Maybe you said something else, and that's totally fine. Like the sum of 7 and 3 times a number. That would work. Let's look at number 4. Ooh, I like doing it this way. 5 less than the product of 2 and a number. I guess it's okay to write the numbers. Number 5, a number squared plus 1 is 8. That works. A number squared plus 1 is 8. And lastly, the quotient, can I spell it? Of 4 times a number and 2. There we go. So we're just translating from the math expression to the English words. So let's take it a little bit further. Let's write the following as a numerical expression or equation. Well, it's going to have a lot of things in it. 1/2 the sum of a number and 4 is 3 less than the quotient of 5 and a number. All right, that's a lot. Right, let's just kind of go as we read it. 1/2 the sum of a number and 4. So got to be careful. We're going to do 1/2 of all of this. This word and connects those two. So 1/2 of all of that. So we're going to sum. So sum is addition. A number is x and 4, right? So we're going to take 1/2 of all of that. And that is, here's that less than phrase. So we want to make sure the 3 comes off the back. So I'll write the 3 here. 3 less than, okay, the quotient of 5 and a number. There we go. So it's not always going to write exactly as you read it, because sometimes the English language, you write it before, and sometimes in the math language it comes after, like that less than. We're looking for clue words too here, like in the English language, all of this would be combined because of that and. Oops. Okay. Your bedroom wall has a length of 12 feet. I always have to draw pictures. Y'all, I'm so visual. And I don't even mind that I'm not that great of an artist. You shouldn't either if you aren't. It's 12 feet long and x feet wide. Write an expression to represent the area of a wall. Well, you do have a formula sheet in this class. We'll talk about that soon. But you probably remember the area of a rectangle is length times width, right? So we would just say 12 times x. That's it. That was easy peasy. Example 3, a rectangular picture frame has a width of 9 centimeters. Oops, that's this one. And a length of x centimeters. Write an expression to represent the perimeter. Again, we do have a formula sheet if you want to peek at it, but I'm guessing you remember perimeter means the distance all the way around a shape. So if this is 9, then that means this is 9. This is x, this is x. So for perimeter, we want to add them all up. We need to know the whole length of the whole outside. So we could say 9 plus 9 plus x plus x. And I mean, that's pretty fine. Or even better would be if we combined like terms. So 18 and 1x plus 1x is 2x. That's it. And this is an expression because there's no equal to, although I'm dying to write it like this. I don't know why. That's what my brain wants to do, but this is an equation. Did ask us to write an expression. So that would be this one. Example 4. It says there are 2 more horses than cows in a field. There are 16 animals in all. How many horses were in the field? Well, it tells us to let C equal the number of cows. So then let's figure out what the number of horses is. It says there are 2 more horses than cows. So the number of horses is 2 more than cows. So 2 plus C equals the number of horses. So to find the total number of animals, we'll just take all of these and add them together. Remember, the number of cows is C, the number of horses is 2 plus C, and that equals 16. So we have 1C plus 1C is 2C plus 2 equals 16. And that is our answer. They don't want us to solve it. They just want you to write the equation that represents the situation. If you're feeling like you want a little bit more practice, I wanted to direct you to our course practice page, and we'll do a quick little tour here. On the left-hand side, you'll find lots of great information about our middle school page, the calculator, tips for success, all kinds of information. But if you go to course review resources, you will find a ton of stuff. So there's some interactive questions here by link. Here's our formula sheet for the course. This one, I think, for now, is going to be your best place to go. So it has videos, practice sheets, links with answer keys. I'll show you. And it's broken down by topic. So we know that we're doing A1. So you can click into here. And let's say you wanted to do this one. See? There is a whole video on it. Actually, there's 3 videos. 4. There's IXL practice. You can practice IXL 10 problems free once a day. If you clear your cache, you can do it more than once a day. And then an additional practice sheet right here with some example problems and an answer key for the sheet. So I'll show you how this answer key works. Look, if it's A1A, if you click here, it's going to bring you to all the answer sheets. Just make sure you go to the one that you're studying. So that's A1A, and it'll load. But if you were going to look at A2B, here's A2B. All right, everyone, thanks for hanging with me. I hope you have a great week, and I'll see you soon.